Okay, Physics 11, carrying on with our math review. We finished up in class on some of our algebra skills that we're going to need in physics class. Hope we're not scaring anyone away so far. It'll become more and more comfortable as you work with the math a little bit. So today we're going to look at scientific notation, unit prefixes, and unit conversions. Other things that we do quite a bit in physics. Scientific notation, well, in physics, the real science, right, we're working with really large numbers. Could be the distance to the moon or something like that. We could have a large number in the hundreds of millions, for instance, 3.26195,482. Maybe that's in kilometers, right? We're all familiar with the units of kilometers. We'll get to that here shortly. But that's an uncomfortable number to write. You kind of lose track of things there. And we notice that nowadays we often don't put commas in between these things anymore. It's become the style. But how significant is that? You know, if I'm sending something, a rocket ship or something, 326 million kilometers away, am I really worried about plus or minus 2 kilometers or even 80 kilometers down here? Looking at those, probably not. For a large number like that, I'm really concerned with those first numbers, the ones in the millions. We have a rule of thumb in physics that we like to express numbers to 2 or 3 digits. That's really as significant as we get, as accurate as we need to be. So here we're going to take this number and we're going to convert it to scientific notation. We're going to make it almost an equivalent value, but with a lot fewer digits shown here. Scientific notation, all sorts of benefits. It's going to help us to estimate whether we get reasonable answers mathematically. So this is equal to, I could put a decimal right here and have this 3.26195,482 times, well, I need 1, 2, 3, 4, 5, 6, 7, 8 more zeros there. 1, 2, 3, 4, 5, 6, 7, 8. That's no easier to write though. But of course this is 10 times itself 8 times, as in 10 to the 8th power. 10 times 10 times 10, and we know we would just add zeros there. And I'm going to round this back to about this, 3.26 times 10 to the 8th. So really quickly and easily, that's converted that into scientific notation. We have, and I always forget the words for them, we have one number in front of the decimal, 1 or 2 numbers or digits behind the decimal. We have a 10 with some multiplier on it. Quickest and easiest way, just count how many places. We started with the decimal right there, even though we didn't draw it, and we moved that decimal 1, 2, 3, 4, 5, 6, 7, 8 places. That's where I get the 8 from, and it was positive 8. That number there has basically the same value as the number at the top. Okay, with a lot fewer digits, then how accurately did we really know those digits? Same thing with small numbers. Maybe we get something with a really small mass, 3.61. Oh, sorry, let me change that here. 0.000361 grams. Put that into scientific notation. Again, I'm going to want one digit in front of the decimal, so I'm going to take that decimal and move it from there over just behind the 3, so it's going to be 3.61, and I moved it 1, 2, 3, 4 decimal places, so it's times 10 to the negative 4 grams. Negative, of course, when it's a negative exponent on something, 10 to the negative 4 is the same as 1 over 10 to the 4th. It's the inverse, right? And 10 to the 4th is 1 over 10 times itself 4 times. 1, 2, 3, 4 zeros. 1/10,000th. That's a pretty small number. That's a small number there as well. Okay, so to change into scientific notation, generally just a matter of counting the decimal places. We get big numbers, we got small numbers, they're all easy to work with. If I were going to take and multiply a number like that, and I'm not sure what the sense is in multiplying kilometers times grams, so I'm going to leave the units off for now. But if I were going 3.26 times 10 to the 8th times 3.61 times 10 to the negative 4th, all I need to do is multiply the numeric part. And again, it's really easy for estimating. 3 times 3 is 9, and that's a little more than 3, and that's a little more than 3. I'm going to guess we're somewhere in the neighborhood of 10 or 11. So I could say, estimate the number here is going to be 10. And then with the exponents on the multipliers here, 10 to the 8th, 10 to the negative 4th, all we do is add them. So 8 plus negative 4 is 10 to the 4th, so it's 10 times 10 to the 4th. Okay, and if I want to put that in proper scientific notation, again, I want to move that decimal over 1. Make that 1 smaller, I sometimes say. So it's 1.0. That needs to be 1 bigger, times 10 to the 5th. 10 to the 5th is 1 decimal place bigger than 1.0 was, or 10 to the 4th was, sorry. Okay, so that's a quick little intro into scientific notation. The next thing we said we were going to look at is a unit prefixes. Now, let's see here. Got a list from the Physics 12 spreadsheet or formula sheet. And you can see here that essentially not a whole, whoops, that's, okay, we pasted that. And not a whole lot different than putting things in scientific notation. These are the most common prefixes we're going to see. Mega, capital M, and that means 10 or 1 million, 10 to the 6. So if something were listed as 4.8 megameters, that means 4.8 times 10 to the 6 meters, right? We can take that capital M and make it a multiplier like that and put that in scientific notation. We've seen that plenty, I'm sure. Kilo, again, thousands, 10 to the 3rd. Deci, don't see quite as often, but centi we see a lot, centimeters, and that's 10 to the negative 2 or 1/100th. Milli, and micro is another one that we're going to commonly see here. So if we see a number like 3.6 micrometers, that would mean 3.6 times 10 to the negative 6. The least familiar ones to you probably are going to be mega and micro. We're all pretty darn familiar with kilo and millimeters. Now, unit conversions. We can use this when we do unit conversions. Let's say we want to convert kilometers into centimeters. Unit conversions. Well, here's what I say, my way of describing unit conversions. When we're converting units, we multiply by 1. Okay, and what do I mean by that? When you multiply by 1, you're not changing anything, right? So multiplying by 1 simply means keeping the same value, the same magnitude, and changing perhaps the units. So if I want to go, I said from kilometers, how many centimeters are in 11.4 kilometers equals how many centimeters? Well, let's see, 11.4, let's go, whoops, 11.4 kilometers, and I'm going to multiply by 1, and I'm going to have a fraction here with kilometers on the bottom and meters on the top, and I need the top to be basically the same value as the bottom. So 1 kilometer is 1,000 meters, right? And then I want to change from, whoops, tends to get away on me there, change from meters to centimeters. So meters is going to become centimeters, and 1 meter is 100 centimeters. So ultimately 11.4 is going to be, and again, top and bottom will divide out. Top and bottom will divide out. I'm left with units here of centimeters. It's 11.4, and I'm going to add 1, 2, 3, 4, 5 zeros. I'm just going to put times 10 to the 5th. Centimeters, not in proper scientific notation. Let me just write underneath here 1.14. That's 1 decimal place smaller than 11.4, so I'm going to make this 1 decimal place bigger, times 10 to the 6 centimeters. So you can see what I mean by multiplying by 1 right over here. This fraction has a magnitude of 1. The numerator is the same value as the denominator, and the same thing here. A more common fraction that we're going to, or sorry, a unit conversion that we're going to see, something like kilometers per hour to meters per second. But I'm going to use exactly the same thing. The only difference is here I'm going to have 2 units in my original value. So let's say 50 kilometers per hour. You're driving along the street and you want to know how many meters per second that is. So I'm going to multiply by 1. So I'll set myself up here, some brackets. It's a fraction. And I want to get rid of kilometers, so I'm going to put kilometers on the bottom, and I want to turn that into meters. So I'll put meters on the top. Kilometers will divide out, top and bottom, numerator divided by denominator, divides to give you 1. I need the value here to be the same, and again, 1,000 meters is 1 kilometer. The value is the same, top and bottom. And then I want to change hours into seconds. I want the hours to divide out, so I got to have it on top there, and seconds on the bottom. Now there's 3,600 seconds. That's 60 minutes times 60 seconds. 6 times 6 is 36. Add a couple of zeros. 3,600 seconds in 1 hour. So 50 kilometers per hour becomes 50 times 1,000 divided by 3,600. And if you like, I can just move 3 decimal places there. 50 divided by 3.6 is equal to 13.889 meters per second. Could have put 13.9 meters per second there. Okay, so all of these things fairly straightforward. Scientific notation, unit prefixes, unit conversions. We're going to use them a lot, and we'll get more and more comfortable with them as we go through our math.